Hello class, today we'll study about Heron's formula. So before we go to the formula, we'll know like who was Heron. Heron was a great mathematician and who born in Egypt, and he wrote a book on finding the area of various plane figures including triangles, squares, rectangles, trapezium, circles, those things. So he wrote multiple books, actually 3 books on mensuration itself, and one is all about the area. Before we go ahead, we'll try to understand what is area of plane figure. So we gave it as the measurement of surface enclosed by its boundary, and its basic unit is centimeter square or meter square. And if we talk about very well known figures like rectangle, area of rectangle is nothing but length into breadth. And area of triangles we know as half into base into height. Next we'll go to triangles. How do we find area of triangles? But before this, I will try to understand how the triangles are categorized. So triangles are categorized on basis of 2 things, sides and angles. So based on sides, there are 3 types of triangles: scalene triangle, isosceles triangle, and equilateral triangles. Based on the angles, we have acute angle, right angle triangle, and obtuse triangle. So if we talk about like how to find the area of triangles, so we can have 2 situations. One situation is like when base and heights are given. So how do we find the area of such kind of triangles? And second situation can be like base, actually height is not given. How we will find the area of such triangle? So how to find the area of triangles when base and height are given? So it's very simple. Area of triangle is half into base into height. If we talk about the first figure, so we have this as triangle, and this we can consider this as base, and this is the height. So half of multiplication of base and height. Second is right angle triangle. So you can take this as base and this as height, or the vice versa. Okay, so area of this right angle triangle is half into base into height. In the third figure, just one thing which you need to focus. So this is the triangle, area of triangle, but to find this we need base into height. The height we can consider this as height, and base from here to here. Please do not take the value of base as this one. This will be wrong. Okay, so half into base into height. While finding the area of triangle, you should remember a few points. Like in a triangle, any of its side can be considered as the base. And second is, height is also sometimes referred as altitude or perpendicular, which is nothing but the length of perpendicular from the opposite vertex to the base. So if we talk about the area of triangle, then we can give a better formula as half into base into corresponding height. It's not like any height you can consider, it's corresponding height. So if we talk about this diagram, so assume this is the height given, so base will be this one, or if this is the base given, height will be this one. In this triangle, it's very clear, this will be base and this will be height. And in this triangle, this will be base and this will be height. So any of the side you can take as base, and corresponding height can be taken accordingly. Now we'll go to this special type of triangles. The second one, that is isosceles triangle. How we will find the area of an isosceles triangle if equal sides are given and base is also given. So this is the base. Assume the length of base is given as b, and this equal sides as a and a. So let's give a name to the triangle ABC, and this is the perpendicular bisector. On this side, give the name as P. Okay, so this is one of the property of an isosceles triangle, where it bisects this side. Perpendicular line bisect the third side. So we can say the whole thing since the whole thing is b, this half will be equal to b by 2. Now you can take any triangle, any half of the triangle to find the area. So basically we know area of triangle is half into base into height. We will use this formula to find the area of an isosceles triangle where direct height is not given. Actually, area should be half into base into height. We have half into b into height. We don't know what is the value of height. How we will find it? So it's nothing but we are going to derive a formula for an isosceles triangle to find the area if height is not given. Okay, so basically all the three sides are given. If we talk about triangle ABP, it's a right angle triangle, so definitely we can use the Pythagoras theorem, which says hypotenuse square is equal to sum of the other sides square. So b by 2 whole square plus AP square. From here, can we write a square minus b square by 4 is equal to AP square. From here, we will get 4a square minus b square by 4 is equal to AP square. From here, can we write AP is equal to root of 4a square minus b square upon 2. So this is nothing but the height which we are looking for. Now, area of triangle ABC, we can write half into base into height, which is equal to half into b into root of 4a square minus b square by 2, which is nothing but 1 by 4 b root of 4a square minus b square. So this is the area of an isosceles triangle. Half, it's not half actually, it's 1 by 4 base into 4a square minus b square. So we will try to avoid this formula directly and we'll go with this derivation, and it will be more simpler. Trust me, it will be very easy finding the area of triangle without using direct formula. So let's take an example. Find the area of an isosceles triangle whose equal sides are 5 cm each and base is 6 cm. So let's take this as the isosceles triangle. This side given, this side is the base. So base is given as 6 cm and equal side 5 cm. Now, to solve this, we can have in fact 3 methods. So we'll just look into 2 methods right now. For the third method we will discuss later. So first method is without using direct formula. So what I mean here without using direct formula is we won't use 1 by 4 into b into under root of whatever, okay, 4b square, 4a square minus b square. So we will just use area is equal to half into base into height. Now draw a perpendicular over here. So this will become 3 cm, this will become 3 cm. Now if we talk about triangle, in triangle AB, let's give the name as P, ABP, hypotenuse square is equal to a square plus b square. Hypotenuse is 5, so 5 square is equal to, we can assume this as a, so this is 3 square plus b square. So this will give you b square is equal to 25 minus 9 is equal to 16 is equal to 4 square, that is b is equal to 4. So basically height you got as 4 cm. Now area of triangle ABC is equal to half into base into height, which is equal to half into 6 into height is 4 cm square is equal to, you can cancel this, 12 cm square. So this is one of the easiest way. You do not need to remember any different or new formula. You can find the area of triangle in a simpler way. Now the next method is area of an isosceles triangle is given by 1 by 4 b into 4a square minus b square, where a is the what is a. So we can assume this as 6 centimeter, a as b, and this is a. So it is simply 1 by 4 into 6 into under root of 4a square, that is 5 square minus 6 square. 3 by 2 under root of 4 into 25 minus 36 is equal to 3 by 2 into 100 minus 36 is equal to 3 by 2 into, that will give you 64. So under root of 64 will be 3 by 2 into 8. Again you'll get 12 centimeter square. So both the ways you can use, but I would prefer this approach, which is very easy. You do not need to remember any new formula. Next is finding the area of an equilateral triangle. As we know, in equilateral triangle all the sides are equal. So let us assume triangle be ABC whose sides are A. Now we'll go with the basic formula and we'll try to derive the direct formula for area of for finding an area of an equilateral triangle. Okay, so the basic formula is half into base into height. So we have base given. What is the height? So again assume this is an isosceles triangle with another side as A. So or in equilateral triangles, again what it will do, it will be A by 2 and A by 2. Now in triangle A B P, again we'll use the Pythagoras theorem. So A square will be equal to A by 2 whole square plus height square. So height square will be equal to A square minus A square by 4, which is nothing but 4A square minus A square by 4, that is 3A square by 4. Now we got the height, we have base. So this is height square. So height will be root 3A by 2. Area of triangle ABC is equal to half base into height. Half base is A, height is root 3A by 2. So this will give you root 3 by 4 A square, that is root 3 by 4 into side square. So this is the derivation of area, derivation for finding the area of an equilateral triangle, root 3 by 4 into side square. Just keep in mind. So this is mostly used in objective questions, and this formula is really easy to remember, so you can use it directly wherever required. So we'll take an example to find the area of an equilateral triangle. Find the area of an equilateral triangle whose side is 2 centimeter. So they have given this as 2 centimeter. Okay. So again we have two ways. We'll go with the basic formula, that is without using direct formula, and then using direct formula. So here area is equal to half into base into height we will use, and here area is equal to root 3 by 4 into side square. So this is very straightforward. You can write area of triangle ABC is equal to root 3 by 4 into side square, that is 2 square centimeter square. So root 3 by 4 into 4 centimeter square, that is root 3 centimeter square, right? So let's talk about the method 1, that is again we need to find the height. So let's draw a perpendicular bisector on side BC. This will be 1 centimeter, this will be 1 centimeter. Take one of the right angle triangle. So using Pythagoras theorem, AB square is equal to BP square plus AP square. So 2 square is equal to 1 square plus AP square. 2 square minus 1 square is equal to AP square is equal to 4 minus 1 is equal to 3. So AP is equal to root of 3. Now area of triangle ABC is equal to half into base into height, which is equal to half into base. Base is 2 centimeter, height is root 3. So again you will get the answer as root 3 centimeter square. Now we'll go back to Heron's formula. What if height is not given and all sides are given? So we'll take a scenario in a triangle. Let's take a triangle. Height is not given and all sides are given. Till now we just know area of any triangle is half into base into height. And if this is not given, how we will find the area of triangle? To deal with this, Heron, the mathematician, gave a formula for finding the area of such triangles. We will learn about that. Okay, so if we see this triangle, area of a triangle is given by S into S minus A, S minus B into S minus C. Now what is S, what is A, we'll learn it very soon. So where S represents the semi-perimeter of the triangle ABC, and ABC are 3 sides. ABC are 3 sides. So the best way to represent everything in a triangle is, if you assume this vertex as A, so this side will be represented by lowercase a. If this is B, opposite to this, this will be B. If this is C, opposite to this, this will be C. Now what is S? S is saying semi-perimeter. So the perimeter of the triangle is nothing but sum of all the sides, that is A plus B plus C. Now its semi means half. So S is equal to A plus B plus C by 2. And area of triangle is given by the formula root of S minus A, S minus B, S minus C. We'll take an example like how to use the Heron's formula. Okay, so find the area of a triangle whose 3 sides are 17 centimeter, 8 centimeter, 15 centimeter long. So if we talk about this, let A is equal to, just draw a triangle and then we'll represent everything. So the semi-perimeter will be A plus B plus C by 2, that is 17 plus 8 plus 15 by 2, that is 20 centimeter. Using Heron's formula, area of triangle is given by this formula, where area is equal to under root of S into S minus A, S minus B and S minus C. So let's find S minus A separately, S separately, S minus B and S minus C. We'll put this all together in the formula, so it will be more simpler. S is equal to 20 centimeter. So S minus A will be equal to how much? 20 minus 17, that is 3 centimeter. S minus B will be this much, 12 centimeter. 20 minus 15 is equal to 5 centimeter. So this can be written as 20, 3, 12, 5. So how many times centimeter, centimeter, centimeter? It's centimeter 4. Or directly you can write it outside as centimeter square, whatever. So basically this thing you can write this as centimeter square also. So this is nothing but root of 20 into, let's write 20 as prime factors, 4 into 5, this will be 3, this will be 4 into 3, this will be 5. So you can see 4, 4 and 5, 5 and 3, 3 are in pair. So it will be 4 into 3 into 5, 60 centimeter square. That's it. So till now what we have learnt is finding the area of triangle by basic formula, half into base into height. Now if the triangle is isosceles triangle, for this we have 1 by 4 base into under root of 4 of a square minus b square. And for equilateral triangle, root 3 by 4 into side square. And another formula, that is Heron's formula we learnt, which is nothing but root of s into s minus a, s minus b, s minus c, where s is equal to a plus b plus c by 2. So these are 4 basic formula we learnt in this chapter till now. Next is what are the different types of questions which are frequently asked from this chapter. First is find the area of triangle whose base and corresponding height are given. This is very simple. We know, or we already know, we can use half into base into height. Half into base into half into base into height. Next is find the area of triangle whose 3 sides are given. So we can use Heron's formula directly. Third is find the area of an isosceles triangle using Heron's formula. So in that case, they will give base and other 2 sides, equal sides, and you need to use the Heron's formula. That is also straightforward. Find the area of an equilateral triangle using Heron's formula. That also we can use. Find the area of a triangle whose 2 sides are given and perimeter is also given. So basically they gave, so what they are talking about this type is 2 sides are given, okay, and perimeter is also given, that is all sum of all the 3 sides. So ultimately we know this side also. Basically all the 3 sides are given. Find the height to one of the corresponding sides, basically one of the corresponding sides, that also we can find. So there is a trick. Here we will be using both the formula, half into base into height and Heron's formula also. So we'll see this later. Next type is find the area of a triangle whose 3 sides are given in some ratio, say x, y, z, and perimeter is given. Then they will ask to find the area. So again they have given the perimeter and they have given the ratio, so we can understand like what all sides will be. Next is like find the cost of turfing a triangular field, watering a triangular field, cost of painting a triangular tiles, etc. So where we need to find the area first and then we need to multiply with the rate applied. Next type is find the area of a quadrilateral whose one diagonal and all sides are given. So it's talking about a quadrilateral. You can take any quadrilateral. Let's take this one. So they have given one diagonal, okay, and all sides they have given A, B, C, D. They have given all the sides. So how to find area of such triangle? So even this is given. So basically this quadrilateral can be divided into 2 triangles. This is one triangle and this is another triangle where all the 3 sides are given. Can't we find the area of both the triangles and sum it up? So that's it. That's the area of a quadrilateral whose one diagonal and all sides are given. Next is find the area of a quadrilateral whose one diagonal and lengths of perpendicular from opposite vertices to the diagonals are given. So if we talk about this, assume this is the quadrilateral and this is one diagonal, and they are telling that this height and this height is given and this is the base. So again we can use half into base into height to find the area of this triangle and this triangle separately, then sum it up. 10th is miscellaneous. There are few miscellaneous questions which are frequently asked from this chapter in exam. We'll go through it one by one in the next video. Don't miss the next video, because that is going to be the base, that is going to make your base, and it will help you to understand how questions are solved from this chapter. So please register on our website for all the benefits, www.Vidyaforyou.com. Follow us on Facebook, and please don't forget to subscribe to our YouTube channel, youtube.com/c/vidyaforyou. Thank you.